Welcome back. Now we're going to shift gears a little bit and talk about how to calculate nominal GDP. And a common phrase that or a common framework that you're going to start seeing a lot of in macro is the distinction between nominal and real. And hopefully this explanation is going to get at some of the distinction of what the difference is between the two. Okay, so set aside any notion of nominal for the time being. Suppose we have an economy that produces sandwiches, beer, surfing lessons, surfboards, and some other things too. Now, for simplicity's sake, we're going to call sandwiches good A, beer good B, surfing lessons, which is technically a service, we're going to call C, surfboards are D, and some other things too. Just to keep this really simple, we're going to say there are only like 3 other things for cereal, and we're going to call them E, F, and G. Now, what information will we need to know about the goods and services being sold in order to calculate nominal GDP for 2018? Well, we would need to know the price of each in 2018, and we would need to know the volume sold of each. So we would need to know how many sandwiches are sold, how much beer is sold, how many hours worth of surfing lessons are hired or purchased, how many surfboards are sold, purchased, and what about the other things? So we would need to know how much of each of these are sold, and we would need to know the price of each of them in order to calculate GDP, or total expenditure, for this given economy in 2018. So basically, we would start by calculating by taking the price of good A, so the price of sandwiches, and we would multiply it by the quantity sold of good A. In this case, the number of sandwiches our little economy's sandwich shop has sold. We would then add that to the price of beer times the quantity of beer sold in 2018, plus the price of surfing lessons times the quantity of surfing lessons consumed or hired, or however you want to think about it, plus the price of surfboards times the quantity of surfboards sold in this given period, plus the price of whatever our next good E is times the quantity sold of it, plus the price of good F times the quantity sold of it, plus the price of good G multiplied by the quantity of good G sold in 2018. And if we add up all of these values, that would give us GDP for our tiny, extremely rarefied economy in the year 2018. If you were going to calculate the size of GDP for a large economy like the US, you can imagine now how complicated it must be. You would need to get the prices of every good and service for sale, and you would need to tabulate how much stuff was actually purchased, how many bunches of grapes, how many, I don't know, how many liters of coffee, how many hours of music lessons, how many restaurant meals, how many of all of these goods and services, this like infinite quantity of things that you could imagine people buying or selling are sold, and what did they sell for? And that tells us basically how much people are spending in an economy, how much people are producing in an economy and successfully selling. And we assume if people are spending this, that they're actually earning the money. So it gives us a way of proxying, of sort of working backwards to establish income in an economy in a given year. So basically this just walks through what I said on the previous slide, but it's typed out so it's a little easier to follow. Now the general formula for nominal GDP, and remember we're talking here about just 1 year, is the sum of all goods and services sold in a given year multiplied by the price of each respective good and service in a given year. Now, I'm not going to test you on this notation, but often in economics, we revert to using Greek notation. So this symbol here that looks like an E is the symbol that says sum of. The price of all goods, where we're saying I is, a stand-in for any number of goods you could have, time in year, the year being analyzed, multiplied by the quantity sold of each particular good in that given year. Price levels and real GDP. Okay, so what's the difference now between nominal and real? Well, nominal refers to the fact that we see a price on a given good. Year to year, that price may stay the same, that price may change. But if we want to compare the volume spent in 2018 and 2019, or 2018 and 2020, or 2018 and 2010, we need to take account of the fact that the prices of these goods may be different. So to compare GDP over time, you need to know how the price level has changed or somehow keep prices constant over time. So the way that economists get around this is by using what we call base year prices. We pick prices for 1 year, and then we calculate GDP using that base year of prices. So let's say we're using 2015 as our base year. Let's say we're using 2015 as our base year. Then we would look at prices from 2015 and the quantity of goods sold in 2015. And if we wanted to compare GDP in 2015 with GDP in 2018 or 2020, we would use those prices from 2015 times the quantity of goods sold or purchased in 2018 and 2020 to actually compare the volume of goods and services and how that's changed over time. Calculating growth rates. Growth rates refer to how a variable changes over time. Is it increasing? Is it decreasing? Is it increasing at a faster rate? Is it decreasing at a faster rate? Or is it staying constant? And the way we measure growth rate is by taking the change in some given variable over time, and we divide it by the original level of the variable. So if you were trying to calculate the growth rate of GDP over time, we might, from say 2017 to 2019, we would look at 2019's GDP minus GDP in 2017, and we would divide that all by GDP in 2019. All right, economic growth and the hockey stick. This diagram shows up relatively late in the chapter, and it refers to the fact that growth accelerated rapidly, starting in roughly the 19th century. So if we compare growth in economies from 1000 to 2000, what we see is that for many large economies that have had importance over world history, we see that, economic activity was roughly constant from the year 1000 until, let's say, 1750. Some point in 1750 onwards, we start seeing rapid development and growth all of a sudden per capita. So GDP starts growing, and it starts growing really, really fast for the UK, for Italy is the green line here, Japan is the red line, China is the purple line, and India is the black line. And what we see is, while the moment of takeoff differs economy by economy, we see this rapid acceleration down here, moving up, starting sometime in the 1700s if we're talking about Britain, starting in the 19th century when we're talking about other economies, and then really getting going in the late 20th century, or the mid 20th century, in countries like India and China. So what was going on? And what effect has that had? How has that revolution in growth affected the environment, and why does that matter to GDP? Well, think about the byproducts of production. Think about the effect on carbon dioxide in the atmosphere. Why would we see this massive change in growth? Why would we see this massive change in carbon dioxide emissions? Well, similar reasons. Mechanization of output increases the potential for growth. The ability to trade fuel over long distances increases the opportunity that economies have to burn energy that generates large emissions. Change in transport technology that facilitates the trade of goods over long distances. All of this is going to matter. Now, why does this all matter to GDP? Why do we care about the effect of emissions? Or why do we care about the effect of growth on the environment? Think about this as you approach your readings, and we'll take some time to talk about it. 2 Wednesdays into the semester.